This past July marked the 50th anniversary of the first landing on the moon, and there's a local tie. A Mount Holyoke professor is studying untouched samples of lunar rocks taken from the moon's surface 50 years ago. I sat down in the studio to talk with Professor Darby Dyar, who was leading the research team for Mount Holyoke and UMass Amherst.
Back in the 1960s and 70s, when NASA brought back the samples, they created a special curatorial facility at Johnson Space Center down in Houston. And in that facility, you have to put on like Tyvek suits and gloves and booties and masks when you go in there, and all the lunar samples are stored very carefully under special gas conditions. But over the ensuing 40 years, many scientists have requested samples to study, and so the vast majority of lunar samples have been exposed to air. So my research is interested in how rocks interact with atmosphere, and since there's no atmosphere on the moon, I was really anxious to see some samples that hadn't seen Earth's air. And so very recently NASA decided to release some samples, the last 6 samples that have never been seen by scientists. Wow. And we were lucky enough to apply and be chosen to work on 4 of them. So we're looking forward to seeing these samples, but we won't let them see air.
Okay, so tell me about some of the samples that you have in front of us that help us understand, what the moon's surface would look like.
So the moon was formed by a collision between an early moon and an early Earth in our solar system. And when that happened, the two bodies kind of commingled, and some of the material melted and sort of swirled around the bigger body and ended up forming the moon. And because of that, the mineralogy on the moon is very simple. There's only a very small number of minerals that are present on the moon. So that's one of the things that makes the moon so interesting, is that the mineralogy is simple. The other thing that makes it interesting is that the moon has been impacted repeatedly. Those big round craters that you see on the moon are mirrored in many different sizes on the surface of the moon. So in fact, there's very little what we would call bedrock as a geologist on the surface of the moon. Most of it is just munched up stuff that's been hit by objects from outer space. And so part of our project will involve sorting through the lunar, we don't call it soil on the moon, we call it regolith. So we'll be sorting through the lunar regolith and looking for tiny glass beads that are remnants of old volcanoes on the moon. Wow. And by studying those, especially the ones that haven't seen Earth's air, we'll be able to get a window into the interior of the moon, and that's what I'm really interested in.
And so when you look at your research, this has to be incredibly exciting because you're about to embark on this. We just had the 50th anniversary of the moon landing and walking on the moon. So that has to be incredibly exciting for you.
It really is. I think of myself as sort of blasé, having had the good fortune to work on lunar samples as a graduate student. And so I've pretty much been working on lunar samples for most of my career. But to have the chance to look at these fresh ones is really exciting. So it's hard to be blasé when you think about being the first eyes and the first instruments to be on these special samples.
And so once you do finish your research, does this lead to other questions and other questions that you might have, endless,
absolutely.
Right?
They're endless. In my research program, it seems like you turn over one rock and there are 10 more underneath it. So we will answer one question, which is how do lunar samples interact with their atmosphere? And we will raise probably at least 10 more. But that leaves something for the next generations to do.
Is there something that has always, that you've always been curious about in your research? You said you've been doing this for 40 years. Is there something that has come up repeatedly and you thought, gee, I wish I could answer this question?
So most of my original research was using a very brute force technique. We had to actually grind samples up in order to study them. And I've spent most of the time since then trying to develop a technology to look at samples at very tiny scales without having to grind them up. And in fact, we've achieved that now. The work that we're going to be doing with the new lunar samples won't actually be done at Mount Holyoke. Some of it will be done at UMass in Amherst on the FTIR system there, but much of it will be done on something called a synchrotron, which is one of these giant nuclear facilities that you read about from the Department of Energy. And I'll be studying these lunar samples both at a facility on Long Island called Brookhaven and at a facility in Illinois called Argonne National Lab.
And so you had mentioned UMass as part of the partnership. Tell me about how that came together.
So many years ago, a colleague there, Sheila Seaman in the Geosciences Department, and I collaborated and were successful in getting an instrument called an infrared spectrometer, a Fourier transform infrared spectrometer, to the Geosciences Department at UMass. And Sheila's been running that facility for at least a decade. And we have worked on lots of terrestrial samples together, and when the opportunity came up to propose to look at lunar samples, I asked Sheila if she wanted to be involved, and she was enthusiastic.
Okay, and tell me a little bit about what you see as the future of the space program in the United States.
That's a very hard question. Right now, NASA is tentatively making plans to send manned missions back to the moon. I have mixed feelings about that because as a scientist, the manned missions tend to be less about science and more about politics, and I'm a scientist, not a person who does politics. On the other hand, as a citizen of the United States, back in the 60s when we were landing on the moon, I remember what it felt like, not as a scientist, but just as a human being, to think about humans going on to other planets. So I have mixed feelings about it. I wish we could get more science out of these manned, or I like to think of them as womaned missions to the moon. And in fact, part of my research now involves developing instrumentation for astronauts to carry around and analyze rocks on surfaces. So we're working with a little unit that is about the size of maybe a small bread box, and it shoots lasers at rocks and tells you what they're made of. So in my research group, we are busy preparing for astronauts to do sorties on all kinds of places, like the moon and maybe Mars. But I think the biggest science comes from rover kinds of missions, like the infamous Mars Science Lab and other such things like that.
And I know you said you don't have the samples yet. Tell me a little bit about the timeline for your research.
So preparing these samples is extremely complicated because I'm going to be looking at samples that are smaller than a grain of salt, and I'm going to be looking at spots on them that are many, many orders of magnitude smaller than a grain of salt. And because we're using such a tiny technique, the surfaces have to be completely flat. So the staff at the Johnson Space Center is busy preparing these samples even as we speak. And so they have to, in a glove box under probably argon or some other gas, they have to prepare these samples in little flat bits, and then they will seal those up in glass capillaries and send them to me. So I'm expecting to get the samples probably sometime early in 2020.